Hello everyone, this is Karthikeyan. I'm a candidate master on code forces, 5-star on CodeChef, ICPC Kanpur Mathura Regionals 2020 rank 27 and global rank 251 in Google Kickstarter Round Day 2021. And today I'm going to discuss the problem, the daily train, which was asked in February 2012 cook-off. The difficulty level of the problem is easy and the number of submissions in the contest were 445. So now let's move on to the problem statement. So, a daily train consists of n cars. Let's consider one particular car. So, basically a daily train consists of n cars and we are considering a particular car. Now, in a particular car, there are 54 places numbered consecutively from 1 to 54. So, there is a train in that there are n cars. Now, in every car, there are 54 consecutive places. Some of them which are already booked and some are still free. Places can either be booked or they can be free. The places are numbered in the following fashion: 1, 2, 3, 4, 5, 7, 6, 8. Here there are multiples of 4: 1 to 4, 5 to 8, 9 to 12, 13 to 16, 17 to 20 till 33 to 36. And here it is 53, 54, 51, 52 till 37, 38. Okay, now the car is separated into 9 compartments of 6 places each. So this particular thing is a compartment. The first 4 and the last 2. Now the second 4 and the second last 2. The third 4 and the third last 2. The fourth 4 and the fourth last 2. And so on till the ninth 4 elements, which is 33 till 36, and the ninth last 2, which is 37 and 38. Okay, now as shown in the picture. So the first compartment consists of places 1, 2, 3, 4, 53 and 54. The second compartment consists of places 5, 6, 7, 8, 51 and 52 and so on. So a group of ex-friends wants to buy tickets for free places. So we can only buy tickets for free places because a place in a train can either be occupied or be free. We can only buy places or ticket for free places, all of which are in one compartment. So basically there are ex-friends. They want to buy tickets for free places which are in the same compartment. In a compartment there are 6 seats and in a car there are 9 compartments. It's much funnier to travel together. So basically they want to buy the ticket of the same compartment because they would have fun. Yeah. You are given the information about the free and booked places in each of the n cars. We are having n cars. Okay. Find the number of ways to sell the friends exactly X tickets in one compartment. Note that the order in which the tickets are sold does not matter. So we basically have to determine that what are the number of possible ways we can sell exactly X tickets to the friends such that all of them sits in the same compartment. And if they are sitting in the same compartment, then they definitely have to be in the same car or the same train. That's big. That's a simple thing. Now, the first line of the input contains two integers x and n, where x denotes the number of friends and n denotes the number of cars. Each of the following n lines contains the information about one car, which is a string of 54 characters, either 0 or 1. If the ith character is 0, then that particular place is free. But if the ith character is 1, then that particular place is booked. And the friends can only buy tickets for free places, not for booked places. We have to output one integer, the requested number of ways, or basically the number of ways we have to tell, such that the X friends sit in a single compartment. Okay, we have to buy X tickets. So basically we can buy tickets from a compartment which has at least X seats free. If the value of X is 5 and the number of free seats are 4, we cannot buy the 5 seats from the 4 free seats. But if the number of free seats are 4 and the number of friends are 3, we can definitely buy 3 seats from the 4 free seats. Okay, buy tickets for the 3 seats. So this is the input format. This particular denoting the number of cars and this denoting the number of friends, denoting the number of cars, number of friends, and then the configuration of each of the cars. Okay, so let's discuss a few things. So we can say that there are 9 compartments. We would calculate the answer per compartment, the number of ways to buy X tickets in every compartment. If the compartment has Y seats free and there are X friends, then the number of ways to buy X tickets from these Y free seats is YCX. And if Y is less than X, then YCX is equal to 0. But if Y is greater than X, ycx is equal to what? Y factorial upon y minus x factorial into x factorial if y is greater than equal to x, or the number of free seats is greater than or equal to the number of friends in a compartment. Now, how the compartments are numbered? The first four, last two, the second four, the second last two, and so on till these these last two nine. Basically, these are the last elements, the elements of the last compartment, and these are the elements of the last compartment. Okay. So this is how we would solve the problem. We would count the number of free seats per compartment, and if the number of free seats per compartment is y, then we would just take ycx. So the answer would be the summation of ycx per compartment. And we would check each and every compartment of each of the n cars. Because if y seats are free and we are having x friends, we want all the friends in the same compartment. So we can calculate the answer per compartment. And if we calculate the answer per compartment, the summation of ycx would give us the answer. Because two compartments are independent of each other. It doesn't matter if the group of friends sit in a particular compartment, then it does not sit in the other compartment because they want to be in the same compartment. So let's move on to my code. This is my code. This is the fact. Fact of 0 denotes the factorial, and fact of I denotes the factorial of I. I initialize the fact of 0 to 1. I iterate through the loop, calculate the fact of I equal to fact of I minus 1 into I. Just be sure by calculating this. This is the NCR function. Now, if n is less than r, be sure to have this base condition to return 0, because if the number of free seats y is less than x, then there is no way to buy x tickets from those y seats. If x is greater than y, then return 0. But if n is greater than equal to r, then the number of ways is n factorial upon n minus 1 n minus r factorial into r factorial, which I have written here. Fact n upon fact n minus r and fact r. This is how this particular pre-computation helps us. If we pre-compute this, we can use this again and again. Now, this is used for fast input and output. I call this pre-compute function before taking the input. Now here x denotes the number of friends, n denotes the number of cars, and I initialize the answer equal to 0, which would be the number of ways to buy x tickets. Now I take the input of x and n. Now I take the input of every car, and the input of a car is taken in the form of a string s. I attach a dollar in the front of the string to get one based indexing. I iterate over the 54 characters, or basically compartment by compartment. How I iterate compartment by compartment? What is the first element of the first compartment? 1. What is the last element of the first compartment? 54. Now, what is the first element of the second compartment? 1 plus 4. So I increment I plus equal to 4. Now, what is the last element of the second compartment? 54 minus 2. So I do j minus equal to 2. And till when I do this, till I is less than j, only then a compartment would be valid, because the last compartment is 33, 34, 35, 36, and 37 and 38. After that, if we continue to do this, then 33 would go to 37 and 37 would come to 35. So I is not less than j, and we won't do that. I initialize f equal to 0, which denotes the number of free seats in the compartment. I iterate over the seats from I to I plus 3 or I to less than I plus 4. And if the current character of the string is 0, then this particular seat is free. And I iterate from j to j minus 1 or greater than j minus 2. And if the current character of the string is 0, then this particular seat is free. So I get the counter of the number of free seats. Now from these f free seats, I want to buy x tickets. So the answer would be NCR of f comma x, which would be FCX if f is greater than equal to x, but 0 if f is less than x. And I add it to the answer, the number of ways to buy exactly x tickets from this particular compartment having f free seats. After this, I would print the answer. So you can see that this is an accepted solution. So if you have any doubts regarding this approach, you can ask in the comment section. And thank you for watching the video.